Hello everyone. So today we will discuss about the thermal stresses in ANSYS Workbench. The objective of this second tutorial is to determine the stresses in an object caused by a uniform temperature change. When a temperature changes occurs in an object, its coefficient of thermal expansion causes an expansion or the contraction of the object depending upon whether the temperature is increasing or decreasing. If the object is unrestrained, there is no stress associated with this free motion. On the other hand, if the object is subjected to restraint against the thermally induced movement, a stress will occur. So, ANSYS Workbench provides tools for the solution of the thermal stresses problems of various types. The temperature change can be uniform throughout the body or distributed due to thermal conditions, such as the temperature distribution in the previous tutorial. First, we will consider a uniform temperature range. So, today's problem is that we have to make two components of two different material and we have to check how the temperature varies from one material to another material. So, we're gonna see it in a practical way. So, open the ANSYS Workbench and drag and drop the project here. First we will set the material. In this we require two materials. So one we are taking as the structural steel and other material is copper alloy. So we are taking this material as our second material. So we'll click on the plus mark so that bookmark is added, which means our material has been set. Now we have to create a geometry. First of all, we will take a plane and we'll draw a rectangular body. We'll set the units. Click on rectangle, draw one rectangle, give dimensions to it. So it is 60 length and 30 height. Now we have to extrude it. Click on apply. Click on add material. So in direction we will choose both symmetric and we'll give the extrusion as 30 and click on generate. So our geometry has generated. Now we have to create one more geometry. So I will hide this sketch first. Now I will create one more sketch. I will give dimensions to it. Length is 30, height is 15. So we have to extrude it now. So we'll click on the sketch, extrude it and click on apply. In the direction we'll select both symmetric and in operation we will select slice material and click on generate. Now here you can see two bodies have been created. Now we have to give the name to the body. So I will right click on it and click on rename. First body will be steel body and second body is copper body. Now we are coming back to our analysis problem. So double click on model. Now first of all we have to check for the material. So for the steel body it is structural steel and for the copper body it should be copper alloy. Okay, so now material has been assigned. And then we have to check for the connections. What are the contacts? So to contact here you can check for the contact. It is a bonded contact. Now click on mesh, click on generate mesh. So our meshing has been done. So now we have to give the conditions here. So in that, first of all, we have to add the temperature condition to the copper body. So I will select this one, geometry, and I will click on apply, and the temperature is 22 degrees centigrade. So I will keeping as it is. Now in this scenario, we'll change the unit first. So because the temperature in this case we required in the Kelvin, so we'll select the Kelvin. Now second condition will be the convection. We'll select the faces for the convection. We'll select this face, this face, so all the faces are selected. Click on apply. Now the film coefficient for this problem is 50 and temperature is 20. Now conditions has been assigned to each of the material. Now we have to click on temperature solution we want it. So we have added the temperature of the entire body. Now click on solution and click on solve. Now we can look for the temperature solution. So here you can see. Now here you can see the temperature varies. So minimum temperature is 265.75 and maximum is 295.15. We'll see in a animated way. So this is how temperature varies between structural steel and the copper alloy material. So we're gonna add one more solution here. We're gonna insert total heat flux and directional heat flux so that we can check for the which direction the heat flux varies. So we'll click on a solution and click on solve. So now this is for the total heat flux. So minimum value is 304.34 and maximum value is 7.6912 E5. So this is how temperature varies. Here you can see from this copper alloy to structural steel. Now for the heat flux. This is for the directional heat flux.